For more videos, subscribe to our channel and hit the bell icon. Make sure to tune in to our next video. Electromagnetic induction. Faraday's first law states that whenever flux linked with a circuit changes, EMF is induced in it. Faraday's second law gives equation for this induced EMF. E equals nd phi by dt. Lenz's law gives direction to this induced EMF. Induced EMF always gives rise to a current whose magnetic field opposes the change in original magnetic flux. Thus EMF have a negative sign. Flux linkage is N phi. Induced EMF can be divided into dynamically induced EMF and statically induced EMF. In case of dynamically induced EMF, there is relative motion between conductor and magnetic field. In case of statically induced EMF, conductors are stationary, field is moving. Statically induced EMF is classified into self-induced EMF and mutually induced EMF. Dynamically induced EMF. When a conductor moves inside a magnetic field, an EMF is induced in it. The magnitude of it is BLV sin theta. B is flux density. L is length of conductor. V is velocity of conductor. Theta is angle between B and V. The direction of EMF is given by Fleming's left-hand rule. It is also called generator rule. Put thumb, forefinger, middle finger in mutually perpendicular directions. If thumb represents force, then forefinger represents field and middle finger represents EMF. This law is used in electric generator. Thus the name generator rule, statically induced EMF. Self-induction is EMF induced due to its own flux change. To study self-induction, take a circuit with a source and a resistor and a coil. When we change resistance, current through circuit changes. It will change flux around the conductor. Whenever flux linked with a circuit changes, EMF is induced in it. It is the EMF induced due to its own flux change. This EMF is E equals minus L di by dt. L equals self-inductance or coefficient of self-induction. L equals N phi by I. L equals N square by S. Where S is the reluctance. Mutually induced EMF. Here change of current in one coil causes an induced EMF in another coil placed near to the first coil. Let L1 is the self-inductance of first coil and L2 is the self-inductance of second coil. M is the mutual inductance between both coil and N1 is turns of first coil and N2 is turns of second coil. Then induced EMF in the second coil is E2 equals minus MdI1 by dt. M equals N2 by I1. L equals N1 N2 by S. Where S is the reluctance. Also coefficient of coupling K equals M by root of L1 L2.